So this video is for you to start your retake requirements. This is a checklist for you to do on another piece of paper. You're going to correct everything using the video. You're going to submit your corrections in both worksheets. There's two review worksheets that we worked on in class. If you need help on those, there's also video help on those. Or you can come visit me. You're going to redo all missed questions on the retake. That would be 1 through 10 on this video, and then the other ones on your own, or get help from me. You'll find lots of problems like those that we did on the handouts and on the problems we did in class. So I'm going to work through problems now on the first page, which was where most of the trouble happened. There's some clarifications on the other pages we'll talk about later. So number one, on any of these, you decide if it's a U substitution if the stuff inside the parentheses for an angle or a power does not have a derivative of 1. If so, it's a U substitution. So I'm going to let U equal 3x plus 4, du equals 3 dx, solve for dx. Then you substitute sine of U, substitute the dx, du over 3. Once you have all u's, you can integrate. Integral of sine is negative cosine. And you replace your u with 3x plus 4. Second one, I'm going to let u equal 2x plus 1. du equals 2 dx. dx equals du over 2. Substitute. Integrate. Raise by 1, divide by that power. So raise it by 1 is the fourth. Divide by that power. And we also still have our 1/2. So your final answer, 1/8. 2x plus 1 to the fourth plus c. Again, examine, see if the stuff in parentheses has a derivative other than just 1. So u equals x squared plus 1. du equals 2x dx. Substitute back in. And make sure that you can cancel something out, so there's only u's left. Integral of u squared is u to the third over 3, or 1/3 u to the third. Put your u back in. Now, a lot of people had trouble with number 4. Again, looking inside, is the angle something that has a derivative other than 1? And it does. So dx is du over 4. Substitute. Always follow your steps. Now you have to decide, do I know the integral of that? Well, think about something that has a derivative of secant tangent, and that would be secant. So 1/4 secant of u plus c. And that's your integral. Remember, you can always take the derivative of what you get, and it should match up. Follow your steps. So du equals negative 2x dx. dx equals du over negative 2x. Substitute. Change to 1/2 power, but we're just substituting out 9 minus x squared. X's cancel out. Integrate, bring your 1/2. U to the 3/2. So that's times 2/3. Which means your final answer is 1/3 x squared plus 1 to the 3/2 plus c. Now we run into one, number 6, where the inside is not a chain rule derivative, but we're going to go ahead and still substitute the inside because we can't do a product rule. Follow your same steps. And then you remember that when du is equal to dx, it's probably going to be a double substitution. So it's straight. Du equals dx, so we take it out. There's still an x, so we have to go back to the u and solve for x. X equals u minus 5. So we have u minus 5 times u to the 1/2 du. We cannot do a product rule integration. So distribute. This becomes u to the 3/2 minus 5u to the 1/2 du. Now you can use your power rule. 2/5 u to the 5/2 minus 5. This is 3/2 times 2/3. So when you do your final substitution, 2/5 x plus 5 to the 5/2 minus 10/3 x plus 5 to the 3/2 plus c. Now we have one that is not a chain rule. It's two separate functions. So we separate it using our sum and difference of integrals rules, which sums and differences can be written as two separate integrals. Integral of x, raise it by 1, divide it by 2. Integral of sine is negative cosine. Now for both of these are definite integrals, so we want to go and plug in our numbers. So when you plug in pi over 2, you get 1/2 pi squared over 4 plus cosine of pi over 2 minus cosine of 0. Always do trig value even if it's 0 because we're not talking about a polynomial. So we have pi squared over 8 plus, this is 0 minus 1. So pi squared over 8 minus 1 is your final answer. Number 8, there was one like this on the review sheet. It's hard to decide which one. Initially you want the cosecant squared to be your u. If you do that, you work through it, you won't be able to cancel everything out. And then so you look at it and say, well, is one of them the derivative of the other, which means we have a chain rule, and the derivative of cotangent is negative cosecant squared. So I want to let my u be cotangent. And then I can solve for dx. Two u cosecant squared x, and now so I just substituted, now I'm going to substitute dx. Now I have my cosecant squareds will cancel out. So I'm just integrating negative 2u du. The integral of 2u is u squared over 2, but the 2's would cancel out. Now this is a good one to check. If you took your derivative here, you would take negative times 2 cotangent of x to the 1 times the derivative of the inside, which is negative cosecant squared, which cancels out the sign. This is a definite integral one. Again, we have a derivative that's not equal to a chain rule, so it might not be a chain rule problem. So you see what you can do. You can try u substitution and let u equal x plus 2, because you've been doing that, and du equals dx. But when you substitute, you still have an x left. So you go back up here and solve for x, and that would be u minus 2. An easier way to do this one, though, is just to multiply your polynomials out. So x squared plus 2x, now it's a simple polynomial. 1/3 x cubed plus x squared, 1 to 0. 1/3 plus 1 minus 0 minus 0, or minus 0 plus 0, which is 1 1/3 or 4/3. Next one, definitely a chain rule. Don't worry about the denominator. Just follow your chain rule steps and see if stuff goes away. Solve for dx. Substitute. And the x squareds will cancel out. So I have a negative out front with a 1/3. U to the negative 2 du. Now be careful when you raise u to the negative 2. You're raising it by 1, so it becomes u to the negative 1. Divide by negative 1 just cancels out the negative out front. And there you have your integral. So most of the mistakes happen on this page. I'm going to show you some other ones as well.